Okay, so this is your lesson on functions and transformations, and we've done this before, but we've done these with linear quadratic functions. We're looking at three new types of functions, and then transformation is something you've already done, but how it would apply to these functions, okay? So if you were able to print out the guided notes, great. If not, you can pause video as you needed to kind of be able to write everything down that you see on here, okay? So let's start, go ahead and fill in the blanks. It says the most basic square root function is f of x equals the radical or square root of x, okay? The square root functions are a subset of radical functions, and they have an endpoint. If you notice here on the graph, I'm not sure if I can annotate here. Hold on, give me a second. Something new I'm trying, so there we go. So you can see here on the graph, you should be able to see that it ends. It doesn't go beyond x equals -0. And then it extends indefinitely in one direction. The reason this works out this way is because this is when you try to input any negative number underneath a square root, it's going to give you error. It's not possible to square root a negative value. So there will be no x equals. Okay, no x, a negative number. So your solutions for any square root function would be have to be 0 or a positive. Okay. Let's look at the other type, and this is called the cubic function. Okay, notice how it looks like an S. It's kind of like a half a parabola, and then the other half is kind of inverted. Okay. And we see this as f of x equals x to the third power. Cubic functions are a subset of polynomial functions, and the ends extend indefinitely in opposite directions. Okay, so we can see that there. And third, we have the cube root function, and that is f of x equals the cubic root of x. Cube roots are a subset of radical functions also, and the ends extend indefinitely also in opposite directions. Only in this case, notice that it's kind of like the cubic function, but turned sideways. All right. Next slide. So let's look at these tables and fill them in, okay? Let's say we were going to go ahead and plug in these x values into the function, and what will be our outputs, and then we'll graph this. So like we mentioned a little bit ago, if I try to square root a -4, I'm actually going to get an error or on a calculator, which will be called an undefined. It's basically, it doesn't exist. Same thing happens with -1. If you try it on your calculator, square root of -1, you will get it undefined. What is the square root of 0? You will be 0. That will be your starting point. Okay. Square root of 1 is 1. Square root of 4 is 2. So how would that graph look like? Well, that graph will look like this. Okay. This is your parent function. There is 0.00. There is 0.11. And there is 0.42. If you continue this, square root of 9 per se, that would be 3. There it is. Everything else in between are basically decimals that you would get. Right? This is the parent function for a square root function. The domain for this is x is greater than or equal to 0. Notice how there's nothing below, nothing to the left of x. And the range how high and how low is y is greater than or equal to 0. It doesn't go below 2 negative y's, okay? Do the same thing for the cubic function. -2 to the third power would give you -8. -2 times -2 times -2. -1 to the third power would give you -1. 0 to the third power would give you 0. 1 to the third power would give you 1. And 2 to the third power would give you 8. So when you plot the points on the graph, that is the way that they would look, okay? So there you go. Notice there's 0, 0, negative 1, negative 1. There's 2, 8. There's 1, 1. And then there's 2, 8. Okay. What is the domain? How far left, how far right? That's all real numbers. Okay. You can plug any X value into here, and you will always get an output. What is the range? How high and how low? This will never stop increasing, never stop decreasing. Your outputs will always continue to increase. So that would also be all real numbers. Okay, so I wanted to take you to Desmos and for you can visually see these transformations. So we have the parent function of the square root of x. As you can see, that looks just like the one we graphed. Notice the next one, by adding +3, it has vertically translated this up. Okay, that was after, there's not inside the radical sign, so it's after the radical sign. Okay, what about when we had -3? I can use the same one. I'm just gonna make it minus. Notice how it has translated down. What happens if you put it inside the radical sign? Notice how even though it's -3, it's moved it 3 to the right. If you do x plus 3, it moves us 3 to the left, so opposite the sign on the horizontal. What does it mean by vertically stretched? Notice how the 3 radical x, or 3 square root of x, it has stretched it, it has pulled it up. So now it's increasing at a faster rate by a factor of 3 in reality, okay? And then what about when it's between 0 and 1? Notice that it's compressed. It has pushed it down together, vertically compressed. So it happens to be running underneath the parent function, okay? So you can do the same thing with Desmos, with the other two functions, but just wanted to show you this here, okay? All right, so last but not least, writing equations from these descriptions. It says write the equation G that results from, and then it gives you a different example. So let's look at these 4 examples real quick. Example A, shifting the f of x equals x to the third up 7 units. Well, we will write the f of x equals x to the third plus 7. It's a vertical shift, so it's outside afterwards, okay? Not inside parentheses. What about a reflection? F of x equals 3 cubic root of x about the x-axis. That would mean then we would write it with basically a negative sign in front. That negative causes it to flip. I didn't show you that on Desmos, but you can go on Desmos and see what happens when it reflects. So translating the square root of x left 5 units. Well, right or left inside the radical sign. Opposite. So it's moving to the left. We would do +5. Normally when we think about plus, we think about going right, but in translations, you got to think opposite the sign. And last but not least, vertically stretching f of x equals x to the third by a factor of 5/2. Simply put that in front of the x to the third. So we have g of x equals 5/2 x to the third. All right, I'll see you on the Zoom on Monday where we'll go over more practice problems and then give you the assignment for the week. Have a great day.